Okay, welcome back to another lesson in chemistry. Here we go. We're looking at the syllabi 0620 chemistry, and we're looking at the topic 2.3 learning outcomes 1 and 2. Here they are. Core learning outcomes. Define isotopes as different atoms of the same element but have the same number of protons but different number of neutrons. Make sure you know that and what that means. We'll be looking at in the next couple of minutes. Interpret and use the symbols for atoms. This one here is an atom, an element of carbon, and this one here is an atom, an ion called chloride ion. We'll look at how we interpret how many each of those separate particles in those atoms are. First of all, let's have a look at a few questions. We want to pose some questions just to get ourselves warmed up, and then hopefully we can work our way through confidently in the next couple of minutes. Can you define what is meant by an isotope of element? Just pause the video, have a speak to yourself or look it up, write something down. And next question, can you give common examples of isotopes of different elements? You may know some, you may not. But if you'd like to try and guess, write them down. Won't do any harm. Remember, you'll always learn from your mistakes. Next slide, we're going to have a look at a bit of knowledge and understanding. Remember here, these numbers have a particular value, nucleon number here at the top, and the proton number here at the bottom. Remember, if it's in a different textbook, remember the smaller number is usually the proton number and the larger number is the nucleon or mass number. So more knowledge and understanding, make sure you understand the definition of isotope. Isotopes are different atoms of the same element, but they have the same number of protons but different number of neutrons. For example, there's plenty of examples, but we're going to have a look at the element of carbon and its three isotopes. Here's the first one. We can see carbon here is the atom. It's got the atomic mass and nucleon number of 12. Here's a second isotope of carbon that exists, various natural percentage, mass number of 13. And here's the third one, same atom, but a different mass number again of 14. So carbon has three isotopes of itself. So triplet, how lovely. Here we are. We'll have a look at how we can understand this. I'll just do the first one for us. So carbon is a neutral here, it's not forming an ion, so we've got 6 protons. Remember, for a neutral element, we have the same number of protons, electrons, so that should have 6. And to work out the number of neutrons, it's the big number, the nucleon number, take away the proton number, and we get this number here. Here we got, again, carbon is 6 protons, 6 electrons, and to work out the number of neutrons, we have a different mass number now. So we take the big number, take away the small number, and we get this one here. You do exactly the same for the next one. Hopefully you're getting the gist of this. Well done if you have already done so. Pose a question. Well, I'm going to have a look at an atom, and this time an ion. If you can name that ion, great. It's a non-metal ion. We call it the chloride ion, just to refresh your mind, the chloride ion. So let's see if we can work out. I'm going to pause this video for 30 seconds to write the number of protons, number of electrons, and work out the number of neutrons. Here are the answers coming now. Protons are 17. We get that directly from this number here at the bottom. Electrons are 18. How do we work that out? It's 17 plus 1, so we can get a full outer shell or rich noble gas configuration, which in theory we say is a stable electronic arrangement. And number of neutrons, again, we work out from 35, the big number, take away 17, and then we get 18. Well done if you got that correct. Next question, we're going to have a look at a positive ion here. This is called the magnesium ion, just to write down. So no change in the ending because it's a metal. So magnesium ion. Let's see if we can work out, pause this video again, and see if you can work out the number of protons, the number of electrons, and number of neutrons. Here are the answers. Hopefully you got them all right. 12. Again, we get them from the number there, which is the proton number. Electrons 10. Remember, it loses 2 electrons. It's got noble gas configuration of 2,8 because it's lost 2 electrons here. And then we've got 12 here because we've got 24. Take away 12. Hopefully we're getting the gist of how we work out the number of neutrons. Well done if you got that correct. Okay, let's have a look at a quick 3. I'd like you to pause the video, have an answer to these questions, write it down. Now, let's first question. Define what is meant by an isotope of an element. Don't look at your notes. See if you can remember off the top of your head. If you can, great. If not, you may need to learn that definition. Question 2, how many protons, electrons do these elements have? Remember, these are neutral elements of oxygen and aluminium, Al. If you remember your first 20 elements that we did in previous slides, well done. And is how many protons, electrons do these elements of ions have? We've got the beryllium ion 2+, and we've got the nitride ion of 3-, which is this one here. That's the nitride ion. Remember, the non-metals end in IDE. Okay, I hope that you paused, and then here come the answers. Have a go at them. Remember, doing these questions helps you learn. Okay, here are the answers. To number 1, define what is meant by an isotope of an element. Isotopes of different atoms of the same element have the same number of protons, but different number of neutrons. So different atoms, same element, same number of protons, different. That would be the important part of that statement that you would have to get correct to get the full marks. How many electrons, protons, and neutrons there are? Here they are for oxygen. Protons is 8. Yeah. Electrons 8 and the neutrons is 8. Remember the 16, take away the 8. Here the big number, take away the smaller number. Aluminium, we've got 13 protons from this number here because that's the proton number. And for a neutral element, it's 13 electrons. And then again, we do 27, which is the big mass number or the nucleon number. Take away the 13, and then we get the 14. And the last question, how are you doing? I hope you're doing really well. Well done if you are. If not, go over it again as many times as you feel you need to. And the final question, we're having a look at the ions. It's a bit tougher, this one, because you have to work out the number of electrons. This is beryllium ion, and then you've got the nitride ion, part B. Here we go. So protons are 4. We get that from there. Electrons are 2. Remember, this is the metal ion. They tend to lose electrons. So that would have been 4, take away 2. Because of the loss of electrons, we'll give you that answer there. And remember here, you've got the 9, take away the 4. For the nucleon number, take away the mass. Then we've got the nitride ion here. Remember, non-metals tend to gain electrons to get a full outer shell. And we can see here it's 10. Remember, 2, 8, and it's in group 5 in your periodic table. Got protons are 7. You work out this, 15, take away 7, which gives you a number 8. And remember, it gained 3 electrons. So it gains 3 electrons to obtain the noble gas configuration of stability. Well done if you got those all right. Fantastic. Good job.